In this movie, we will see how to conduct a multiple regression analysis in JMP. Now, multiple regression is when we have as one dependent variable, and instead of one, in simple regression, we have multiple independent variables. So in this example, we have a data set on used Toyota Corollas from a dealership in Europe. We have price in euros, and that is our outcome variable. We want to predict or find the relationship on price and our other predictive variables. So some of the feature variables that we have are age and months of the cars, mileage in kilometers, the fuel type, horsepower, whether the car had a metallic color, whether the car had an automatic transmission or not, their CC, doors, etc. So our job is to build a model which can explain the relationship between our predictor variables or our X variables on the price of these cars. So just to illustrate the methodology, we will look at age, mileage, automatic, and the horsepower of the car as predictor variables. So to construct a regression model, we will go to the Analyze platform. We'll click on Fit Model. And now we can just drag and drop our variables to the respective roles. Price is our Y variable. We can drag price. Then we can control select age, mileage, horsepower, and the type of transmission. And we can then click on Add, or we can drag them into this box. So we click Add, these variables get added. The default in JMP, when we have a continuous dependent variable, as seen by this histogram to the left of the variable, is it's going to be looking at ordinary least squares. If we had a qualitative variable, we'll look at different categories of model estimation. And then once we have the model set up, we can click Run. And this is our regression output that we get. When we start looking at how to interpret a regression model, one of the first things we want to look at is that we shouldn't see any patterns in the residuals, which is the difference between our actual price and the predicted price in the model and our predicted price. So here we see that everything is clustered around 0, so there doesn't seem to be any patterns. And what this ensures is that if we don't see any patterns in our errors, then most likely our standard errors that we calculate will be correct. And as we have seen in t-test, we use standard errors to conduct test of hypotheses around our various parameters. So here, let's start looking at the regression results. The first thing we look at is the R-square, which tells us what percentage of the variation in the data is captured by the model. And our R-square value is 0.8. So which tells us that 80% of the variation in our actual data has been captured by the model, which is a fairly decent R-square. So our model has a reasonably okay goodness of fit. Then in terms of interpreting the coefficients, each estimate tells us the effect of a unit change in our variable or predictive variable on our outcome variable. So for example, we know that our age is given in months. So this minus 175 tells us that each additional month to the age of the car decreases the price by 175 euros. And again, we can use the units to interpret these numbers. Mileage, our coefficient is minus 0.01, which tells us that every additional kilometer the car is driven decreases the price by 0.1 euros. Automatic, our coefficient is 671, which tells us, because automatic is a binary variable, we have a 0, 1, either the car has automatic transmission or manual transmission. So the reference group is manual transmission. So what this tells us is, compared to a manual transmission on the car, automatic transmission increases the price by 671 euros. And then we can look at the t-ratios. The t-ratios are testing the hypothesis that each of these individual coefficient estimates is 0. In other words, suppose we say that automatic transmission does not have any impact on the price of the car. Even though we got a number 671, we could have gotten a number 0 in a different draw of the sample. So to conduct this test, we will formulate our t-statistic. Our null hypothesis is that the actual value of this parameter is 0. And the t-statistics is giving us a statistic to test that, and that's our t-ratio. Our t-ratio is 2.73, and the p-value is 0.0065, which tells us that the probability that our sample comes from a population where automatic transmission has no impact on the price is only 0.0065. So which is a small probability. So we reject the null and we say that our automatic transmission has an impact on the price of the car. So in a nutshell, this is kind of how we will be conducting a multiple regression analysis in JMP. We could use the analyze platform. We put our variables into the roles that we want them to be. Our y is our dependent or our outcome variable, and our x are our dependent variables. And then we can start looking at some of the output we get from the regression results. Even though we get a lot of output, we want to start by looking at no patterns in our residuals against the predicted value. And then we can look at the goodness of fit by examining the R-square and the adjusted R-square. And then we can start interpreting the coefficients by looking at the individual estimates. And each estimate tells us the impact that this particular variable, in this case age, has on the price of the car, keeping everything else constant.